I don't know what you say. Oh, it burns. My eyes, they burn.
Yes. You weren't here, right? Yeah, I'll give you a copy. There's going to be another shorter version of this today. So if you want both, I can give you both, or you can just stick with it, and I'll also allow you tomorrow to decide whether or not you want to take the test or put it off. You were absent for how many days? Right.
Yeah. I need how this.
All right, everyone listen up. Here's what we're going to do. I usually don't do this, like go over, I mean, you already know the answers, but I do want to go over every category and maybe just go over the tricky ones. Remember, I said it's just probably bad practice to, after a 5-day break, to give you a test. So some of you probably are ready right now to take the test and do fine on it. Others of you will welcome the fact that we're going to do one more day of review. I'm going to give you a much shorter review sheet. It's going to look exactly the same. I mean, different problems, right? But it's going to be the same things. I'm not adding anything to it. But instead of giving you, let's see, I gave you 10, or I gave you more. I gave you 16 of these, or 20 of them? 20 of them. No, I was right. It was 10. I gave you 10 of these. Maybe I only give you, I forget what, 4 or something like that. But just so that it's a little bit of a brush up on what we did. So we'll go over this. We'll just go around the room real quick. We'll do it as fast as you can give me answers. Now, granted, you already know the answers because they were on the back. But if there's something that you look at and you're like, wait a minute, why is that a rhombus? Or why is that an isosceles trapezoid? You know, we can stop and we can talk about it. Lastly, just remember, it is an open notes test, you know, a book of truth type thing. Just make sure that you have access to those pages that are necessary. There's one proof on the test. The rest is going to look exactly like what's in front of your face right now and the review sheet that I give you tonight. So we'll start with Seth. The first one is a?
Oh, rectangle.
It is a rectangle. Is there anything, it says name the most specific name. If you name that a quadrilateral, are you correct? You are correct. It is a quadrilateral, but it says the most specific name. So what type of quadrilateral? It is a rectangle. All right. Jenna, number 2. Note, if you put trapezoid, it is absolutely a trapezoid. But notice the left side and the right side, if you can see my mouse moving here, the left side and the right side are both 6.6. Remember, those are the names of the legs. So it is an isosceles trapezoid. And it just notice, just so that we can see, notice once again on an isosceles trapezoid, the base angles are exactly the same, 60 and 60, 120. So if I were sneaky, I could give you no side lengths at all and just the angle measurements, and you would still need to be able to come up with isosceles trapezoid. It's the only one. Well, that and a right trapezoid, right? One of the angles would be 90 degrees. Okay, very good. All right, what do you got? Number 3? Is it anything other than a parallelogram? Like it could be a rhombus, right? If it looked, but if it was a rhombus, remember all 4 sides would be exactly the same, and this one's not, so it's definitely just a parallelogram. Chandler, number 4. All right, look at the shape.
I got it.
Chandler, look at the shape. Look at the shape, not me. It's on the board. It is a rhombus. Notice the difference between 3 and 4. They both kind of look like the same. They're both parallelograms, but 4 is a rhombus because all the sides are the same. Notice you can't tell whether it's a rhombus or a parallelogram by its angles. Notice the opposite angles are exactly the same. They're congruent on both rhombus and parallelogram. But on the rhombus, the sides are the same. On a parallelogram, the opposite sides are congruent. All right, who we left off on? Matt, number 5? There's a square. Hopefully you don't mess that one up. Danny, number 6. What do you notice about number 6? There's no numbers. What else do you notice? There's no angles. What else do you know? Okay, how many sides are the same? So now you look at your little book of truth where you had quadrilaterals, the one page, and you see what quadrilateral has all 4 sides congruent. It is a rhombus. Good job. All right, number 7, Chris. It is a trapezoid. Now, it certainly looks like a right trapezoid. If you put right trapezoid, I know why, because it probably is a right trapezoid. But notice I don't have the indicator. There's no mark there for the right angle. So we might have a debate about, I mean, I'm not going to put something that, you know, that's kind of a tricky question right there. So yeah, it is probably a right trapezoid, but we don't have an indicator that it's a right angle, so we're just gonna put trapezoid. All right, what do we got? Connor, number 8. Parallelogram. Number 9. Cadence, what do you think? It's a rectangle. All right, number 10, Madison. Ooh, you better put isosceles trapezoid. Not only is it a trapezoid, but the legs are congruent, therefore isosceles trapezoid. All right, now we get to the first, I don't know, maybe challenging one. This is the one that you will screw up. So this is where you open up your book of truth and it says, find the measurement of each parallelogram. So let's see. Parallelogram, they're either going to ask us angle measurements or they're going to ask us side measurements. On a parallelogram, opposite sides are, opposite angles are, and consecutive angles or angles next to each other are supplementary. Those 3 ideas. If the 2 angles are next to each other, they add up to 180. If the 2 angles are opposite each other, they're congruent. If the sides are opposite each other, they're congruent, and those are the basic 3 rules. So who do we leave off on? Go ahead. And what's the answer? 65 and 115 are 180. Notice the 2 angles are next to each other. Therefore, angle S is 65 degrees. Good job. Micah, number 12. 140. The angles are next to each other. Bailey, number 13. 139. They're next to each other. Did I give you all of them next to each other? It looks that way. I should have gave you at least one that were opposite. Just remember, if they're opposite, they're congruent. All right. What do we got? Amaya, 14? 100. Very good. And the last one, I literally gave you every one where they're next to each other instead of opposite. So I apologize on that. I should have given you a couple that were opposite each other. All right. Yeah, exactly. Seth, 15? 75. All right. 16 comes the first one, and now I gave you 2. Now, if you have the test, and you're wondering, 16 is kind of iffy because of the numbers, right? If you can't tell that this belongs to angle R and this belongs to angle T, just ask me, confirm it with me before you do your calculation. Notice, Jenna, these 2 angles are what? Next to each other or opposite each other? So therefore, what's the setup? If they're opposite, then they're equal. So we literally put an equal sign. It says find the measurement of angle R. So we set them equal to each other. So 4 plus 14x is equal to -5 plus 15x. You've done problems like this for other shapes and whatnot. I'm not going to get into it. Solve that equation, find the answer for x. By the way, x is equal to, what is it? X is equal to not 130, x is equal to 9. Now we plug in 9 back in here. We do some more math and we find that the answer is it 130? Okay. All right. Questions on that? All right. So you're going to call out, obviously the answers are in the back. You can already check them. But if there's one of these that you look at and you're like, well, how do you get that? For instance, on number 17, that would be the other type. Seth, what's the setup for 17?
Setup for 17 is,
here's angle B, here's angle W.
yeah, angle B and angle W added equals 180.
Yes? So that would be 14x plus 1, that's angle V, plus 16x minus 1, that's angle W, 16x. Together they equal 180. Now we got to solve that one. 16 and 14 are what, 30? And 1 minus 1 is 0, so we get 30. 30x equals 180, therefore x equals 6. Then we take 6 and it says B. You can still screw this up, right? Make sure you pick the right angle. So we're looking for angle V. So plug in 6 for x there. 14 times 6 is what, 84? Is that right? And then 84 plus 1 is 85. Okay? Yes? Yeah. Confident? Not confident? On those? I mean, I gave you a lot. How many did I give you of these? How many did I give you like this? Those are the only 2 ways it's done. There's no other like weird thing there for angles. I want to give you, say I gave you 8 of them. No, I gave you 4 of them. So I gave you 4 of those. And then 21, we pick up with side measurements. Okay. Danny, 21. How big is EH? Look at it. Yeah, it literally is that simple, right? Opposite sides are congruent. The only way I can make this more challenging is to give you some variables. 26, the first one. So on 26, notice one side is 2x minus 6, one side is x. What do we know about the relationship between opposite sides? They're equal. They don't equal 180. They are equal. So 2x minus 6 is equal to the other side is x. Solve that equation. A couple of you still are having trouble with equations that look like this. Like you're uncomfortable with what happens next. You need to get the x's on the same side, and you do minus x, and you're uncomfortable with writing, what's x minus x?
0.
You're uncomfortable with writing 0. It's okay. 0 is a number, right? So x minus x is truly 0. 2x minus x is x, so we get x minus 6. If you could get past that step, you would see that the answer is, if we solve for x is 6, throw 6 in for what are we solving? FE, be careful, right? Oh, by the way, the sides are congruent, so therefore you could use either one. But in this case, FE is this side, but if you realize that, by the way, both sides have to be equal, you can just plug it into that one and already know the answer is 6. Oh, by the way, 12 minus 6 is still 6. 2 times 6 is 12. 12 minus 6 is 6. Okay? Be comfortable with that. It's okay. Questions? So solving for sides and solving for angles of parallelograms, that's the whole ball of wax right there. Should be easy, easy, easy money on the test for those. The more complicated ones, and usually if you're going to make a mistake, it's on these. So we got parallelogram. The other thing that we get for parallelogram is we talk about the diagonals. What do we know about the diagonals of parallelograms? They bisect each other. We got some more stuff. If it's a rectangle, then not only do they bisect each other, they're congruent. For a rhombus, they intersect at 90-degree angles. We got all that stuff as well too. But the basic idea here is if you have a parallelogram, by the way, rhombus is parallelogram, that the diagonals cut each other in half. Now notice, this is not the same length as this. So we get a long piece and we get a short piece. Only when it's a rectangle or a square do the diagonals equal each other. But for your standard parallelogram, you're always going to have a short one and a long one, okay? But they bisect each other. They cut each other in half. If you're going to make a mistake, it's because you're not paying attention, so just be careful. Colored pencils might help, a highlighter. It says VL is 18. You find VL, here's VL, and we know that's 18. Immediately, before I read even anything else, what can you tell me, Bailey, about this? If this is 18, then immediately what could you say? Ignore what it says. If this is 18, then is what? Which one is which? Say it again. It's a V, but Vx would be double. You could also say, that's true, good job. You could also say, she said that Vx would be double 18, so it's 36. You could also say that this side is, therefore it's the same, therefore it's, thank you. All right, that was good, that was good. Okay, notice it doesn't say anything about this side. Now it says find Vx, so we know that Vx was, Bailey said double that, so 36. Easy, easy stuff. If you make a mistake, it's because you don't pay attention to what it's asking. You know what it's supposed to happen, but you get confused by, well, maybe they're asking for the whole piece, or maybe they're asking for the opposite side. Just be careful. The other way that this can be asked, if they give you the whole piece and ask you to find half of the piece, right? That one's not, where's an example one like that?
That's
33? 33, though, I thought it gives you half. Give me one that gives me the whole thing. BL, EC, yeah, okay, 32. Look at 32. 32, it says the EC is 28. So me, once again, I'm going to use a marker or something. That piece right there is 28. Therefore, even before I look at the question, I know if that's 28, I know that this piece is half of 28, therefore it's, and therefore that piece is, okay, now we answer the question. Oh, it's asking for that piece, it's 14. Who's lost on that? How can I make this more challenging? Instead of giving you numbers, I give you variables, okay? So when I give you variables, it's the same darn problems, it's just got variables in there. So you just have to be comfortable with this process of doing it with variables. Question 36. Notice it says that KF is short piece. That's x plus 9. So I know immediately that this side has to be, and the whole thing needs to be double x plus 9. So it tells me two pieces. It says that KF is x plus 9 and KM, right? The whole thing is that. So what's the setup? This piece is equal to what of this? This piece is equal to what of this? Well, you're saying it backwards. This piece is equal to double the big piece. If you want to say that the long piece is half of the long piece is that, you could say that as well too. What do you like to do? Double things or divide by 2? Who likes dividing by 2? Who likes doubling things? You can do it either way. I personally think doubling is easier than taking half because you got to write a fraction to divide by half. So for me, I'm going to take this thing and double it and say it's equal to the whole thing. How big is this piece? Well, it says it's x plus 9. Well, I said that double it, is equal to the other piece, and it says the other piece is 5x minus 6. Solve that equation, right? A lot of people would probably double this in their head even before they started, right? So they might write 2x plus 18, and okay, they're still doing that. And that equals 5x minus 6. A little bit of algebra, move 2x to that side, add 6 to that side. We get what? 24 is equal to 3x, therefore x is equal to, I added 6 to both sides. Yeah. I subtracted 2x from both sides, therefore x is equal to 3. Or sorry, x is equal to 8. Yeah? Okay. It says find KF. KF is this piece. You just said that x is equal to 8. 8 plus 9 is, I'm not claiming this is simple, so simple you can do it in your head. You can't. You got to do the algebra, but hopefully you understand the relationship between the parts that cut in half. If you want to use, Matt said he wants to divide by 2, so what we'd have to do, we'd have to write 5x minus, 6, the whole thing divided by 2, and that's equal to x plus 9. And that's, I'm not saying that algebraically it's harder, but a lot of kids, when they're stuck with this, they're like, well, I don't know what to do next. What should you do next? Okay, but then you got to divide 5 by 2. So that's what you would do? Okay, could you do that? You could. You could also multiply both sides by 2 and it gets rid of that 2. Then it turns into that, by the way. So why not just set it that way? If you want to do what Matt said, well, we got to divide 5 by 2. What's 5 divided by 2? So you would write 2.5x minus 3 is equal to x plus 9. You see the, okay, if you can do this, you like working with decimals? What if we were dividing by 3 and it turns into a repeating decimal type thing? You know what I mean? So this is why I would recommend this, you know, that over, or set up like this and multiplies both sides by 2. By the way, that would turn into that, so I'm saving this step. So if you notice, you're going to see a pattern when I teach is that even though the book will show so many things divided by 2, I typically just multiply the opposite side by 2 and not get rid of division every single time. All right, questions on parallelograms? All right, move on. Next category. Once again, I'm not going over the answers because the answers, I gave them to you. All right. So the next one, the one that's kind of forgettable, is this one. Connor, do you remember what we do here? You have a triangle and you have its median. In other words, you have a second segment kind of in the middle of the triangle, right? And what it does is it connects the midpoint of 2 of the sides of the triangle. Remember what we do? Oh, Connor's. So what's the relationship between the short side and the long side? Okay. When I say relationship, like mathematically, is it triple? Is it a fourth? Is it double? Is it half? That sort of thing. It's a half. The short piece, this piece that I'm touching right now, FE, is half of the long side. By the way, we also got that second part that we said that if it goes to the middle, that is parallel to the opposite side. In other words, FE is parallel to W. That was cool. We used that to prove some things, but not much useful other than that. What was useful is that we can determine the distance of it. We can say that FE is half W, therefore Connor, FE is how big? How big? 6. Because half of 18 is 6, right? Half of 18? What times 2 is 18? You got this? 9, right? Remember, you can have a calculator on the test. Please use a calculator. Oh, that's rude. All right. Let's do this real quick. 42. What do you got, Cadence? Okay. Jenna, if this is 11, how big is a long piece? Okay. Danny, number 44. If UT is 6, how long is LJ? Perfect. Good job. All right. How can I make that more harder, more challenging? I simply put some variables. So let's do one of those. All right. So 47. Connor, what's the relationship between the short side and the long side? Okay, it's half. I'm going to go Mr. C thing. Do I like to take half or do I like to double things? I like to double. I find it easier to multiply by 2 than divide by 2. So am I going to double the long piece or am I going to double the short piece? Let's double the short piece. So if I double -7 plus 2x, I would get. So usually high school algebra, I leave off some steps. This would probably be one of the ones that I would expect you should be able to do. If you can't, then you write it out. 2 times -7 plus 2x, and that equals 2x plus 4. But certainly some of you would say, well, that's stupid. I could just write, and you would get it wrong. Yes. Maybe I should take back what I just said. Maybe we need to stick to writing things out. Okay. So we get that. We saw, once again, I'm going to move the 2x to the other side. So I'm going to subtract 2x from both sides. I'm going to add 14 to both sides. So I get 2x. I add 14 to both sides. I get 18. Therefore, x is equal to 9. All right. We apparently like 9s here. Seems like we did a lot of work. By the way, we didn't answer the question, which was how long is WV? But we did find that x is equal to 9. 2 times 9 is 18. 18 minus 7 is 18 minus 7 is 11. Man, take a deep breath, get some oxygen. All right.
It's these sneaking masks. It's ruining my brain.
All right. We're getting close to the end here. Yes. Let's finish this first. All right. So now we move to trapezoids. 2 things on trapezoids. First off, we get the basic idea of trapezoid. So you get one set of parallel sides. Notice we have an isosceles trapezoid, so we get one extra thing. And that's the base angles. This one and this one are congruent. This one and this one are congruent. And what's the relationship between 109 and question mark? They're supplementary. Why? Because remember, these 2 lines are parallel, cut by this transversal. So this plus this equals 180. So in other words, 180 minus 109 is
109. No.
71. Okay? Questions on that? And these are the pretty simple ones. Obviously, if I wanted to, I could put some variables in there to make it more challenging. But you got to remember that relationship. If it's something you think you're going to forget, then you should be writing it down right now. By the way, this is the test. No joke, this is the test. So I'm either going to give you 2 angles that are supplementary, or I will give you 2 angles that are opposite each other, or adjacent to each other, left to right, therefore they are congruent. I guess the last way I can mess with you is if I give you a right trapezoid. Well, that's pretty easy. If this one's 90 degrees, then this one is 90 degrees, okay? Okay. Well, that's true for a rectangle, but remember, the opposite sides of the legs are not parallel. Therefore, not all 4 of them are going to be 90. Okay, but if it was a parallelogram, you're correct. All right, the last thing is this. So it's got that same flavor as that triangle sucker, right? It's got that half thing going on. You just got to remember the relationship. Connor, back to you again. What's the relationship between the middle and the two parallel sides? Say again. The middle is half not of the opposite sides. It's half of the sum of the two opposite sides. By opposite sides, we mean the two bases. Okay? So I can give you ugly numbers. Also notice it's kind of confusing on number 59. Where does the 18.2 go? Does 18.2 go on the bottom or does it go to the middle? All right, so if there's any confusion on the test, wait, is this the bottom or is it the middle? Where, just ask me a question, I'll tell you. So Connor said that the middle is half of the sum of the other two. Once again, I'm more of a double guy. So I'm going to say that the middle, if you double the middle, that's going to equal the sum of the two bases. Like I said, I just don't like dividing by 2. So if I double the middle, that will be double 18.2, and that's equal to the sum of the other two sides. Well, the other two sides are 10.4 and question mark, so plus x. So there's my setup. So if we double 18.2, we get what? 36.4 equals 10.4 equals plus x. Subtract 10.4. Luckily, the numbers are nice and friendly right here. So we get what? 26. So we get 26 is equal to x. And, well, that was easy. Okay. If you like to do half, well, then you got to set up that this side is equal to half the sum of the other two sides. So if you don't want to set it up like this, then you would have to set it up like that. The sum of 10.4 and x divided, the whole thing, divided by 2, is equal to the other side. I agree. And like I said, the first step would be you multiply both sides by 2 to get rid of the fraction. Clear the fraction from last year, right? So it ends up being exactly the way I had mine set up from the start. So I'm going to claim that mine is more efficient, and I don't have to do division. Questions on that? All right. How many people did the whole worksheet? I mean, you did the whole worksheet. No one? How many people did enough that you were like, okay, I got this? Okay, well, that's what we want. All right. All right, so that was the whole darn thing. One sec, I got you. So I'm going to hand you out the worksheet. All right. This one is a much shorter, abbreviated version. How many ones did I give you on this one? 60. This time I'm giving you 42. So I'm just going to say, once again, pick your categories, right? And I need you to be, I don't want to say adult about this, but I need you to be smart about this, right? If it's something you know that you're getting wrong and you're like, he said I can do as many as I want, I'm doing none of them, you're not being smart about it, right? Be smart about it. Clear the first ones, name the quadrilateral. I mean, if you're like, I can get that, I don't need to practice on that, then don't do it. But for the other stuff, I would do at least half of them, right? Just to make sure, confirm. And for those of you that are getting them wrong, then do all of them. All right. Thank you. Oh my gosh. You need to buy a relief tube.
A diaper. Oh, yes. Because that's why he sits in the back of the class.
You know, on airplanes, right? If there's only one pilot, they're not allowed legally to go to the bathroom.
Not even with the autopilot?
Can't. So you know what they do?
Pee their pants.
Huh? They have literally what's called a relief tube. They can do that as well too. That's what fighter pilots do. They wear that. But for commercial pilots, they have a tube right next to their leg, right, that they can grab and they can do their business. All right, on that random, irrelevant bit of trivia, e-learners, are you here today? You are not. So if you have any questions, send me an email. I'm going to stop the test is tomorrow. Make sure you study resource card. Make sure you do your test. Catch you. So no class tomorrow, just the test. We'll meet together again on Thursday.